Today, we're going to learn about Docker. It's a very big topic, so it would take a lot more than just 1 hour, but we'll try to cover it in a short amount of time, and we'll try to be directed on one example. And so the example that we're going to see is actually was suggested by Fadi. And the situation is let's imagine that you're going to present some notebooks for a tutorial that you're giving somewhere. So for instance, these notebooks that have been prepared by Fadi for some lecture that he was giving. The question is, you want people to be able to run those notebooks on their own computer, but you know that it will take the entire session for everyone to install all the dependencies. So here, for instance, in Fadi's case, is demonstrating how to use Octave. But if you ask people to install Octave during the session, forget about it. So the thing that we're going to show today is how we can package everything that's needed to run these notebooks inside a container, and how people can just then grab the container and trivially run the notebooks on their own computer. So that's one use case. There are many others, but hopefully with the little things that we've learned today, you'll be able to extend Docker to other use cases that you might have. All right, so what we'll learn is what is Docker, and more generally, what is a container, how to build one of these containers, how to run one, how to build one, and how to host them so that anyone on Earth can easily download them and run them. And so the prerequisite that we'll assume is that you've managed to install Docker on your system. If you haven't, feel free to talk to me afterwards, but you can, I guess, try to follow along and see what the steps would be. Okay, so step one is trying to understand a little bit more what Docker is. So it can be confusing. It used to be very confusing to me, but once you grab the idea, it's fairly simple. Right, so what is a Docker container? It's essentially a container is something that packages together both the executables and the libraries that you need in order to run those executables. So it's a little bit reminiscent to virtual machines. So if you remember things like VMware or VirtualBox, virtual machine is a complete OS environment that runs on top of your OS. So here you have an illustration of that, of a machine where you have the server or your actual physical PC. And that PC runs an OS, so that can be Linux, Windows, or Mac OS. Then on top of that OS, you can run virtual machine. So virtual machine is its own OS, so it can be Ubuntu again on top of Mac OS, for instance. And then on top of that Ubuntu system, you have a few binaries and libraries and the actual application that you're interested in. So that's fairly heavy. And if you have several applications that have different requirements, or that even have the same requirements, they need this entire stack, and the stacks cannot be shared. And so it's very heavy. When you want to run your application, you need to boot the OS first inside the virtual machine and all of these type of things. So what containers do is that they essentially remove the middleman here. They remove the guest OS. And what they allow you to do is to package your application as just a tiny layer of application-specific binaries and libraries that can even be shared between different applications. And all of that runs on top of the Docker engine, which emulates a Linux kernel and directly runs on top of your OS. So the main difference between this system and the previous virtual machine system is that there is no longer the need for guest OS. Everything runs on the same emulated OS that's provided by Docker. And the nicest thing is that if you have libraries that are common for different applications, they can be shared so that you can actually save space. So in practice, what you'll see is that when you want to run an application, it will run essentially just as fast as a native application on your system. You don't actually need to boot a whole virtual machine in order to run it. Any questions at this point? Or is that clear, more or less?
Yeah, I have one question. Mm-hmm. If one application needs some data, do you need to put the data from the beginning in the container, or you can put later some data?
Exactly. So that's a great question. So you can package your data with the container if you want. So it will be, so the container is actually a small file system. And inside that file system, you have the libraries and binaries that you need. You can also put some data files inside that container. So that's one strategy. The other strategy is that you'll be able, and we'll see how to do that, you can mount a local folder inside the container so that you can access your local files on your local machines from tools that are containerized. And so that's the most useful situation because you can access your normal environment through tools that are containerized. And we'll see how to do that. All right. So then the question is, how do you actually build a system where you can actually share common tools between different containers? So the way this works is that in Docker, a Docker image, which is, you know, like the file system for a container, is layered. And so you build a Docker image by adding layers on top of layers. And if you have common layers between different containers, they are shared between those containers. So here is an illustration where you want to build a Docker container that with your own sources on top of this. But in order to have that, you first need to have some web server installed and then some Git on top of that web server. So here is how you would do this. You would have like a base image, this image.1, and then on top of that, you can add like a web server. Then you can define a second container that reuses this base image, adds some Git layers on top of that, and then your final thing that just adds your own sources file on top of the previous things and gets the whole thing packaged. And so what you see is that at the end, the container that you use for your purposes is a stack of layers that have been progressively added on top of each other. And so the cool thing is that if now you have two containers that use a lot of the base elements, they share the base layers together and you save time and space between different containers. And so here is an illustration of 4 containers that rely on different layers. So for instance, the base layer in one case can be based on some Ubuntu system or some CentOS system. And the one that are based on the same system share the base layer, but then they diverge at that point. Or you can have other kind of structure. So the bottom line is a container is a stack of layers, and layers that are common between different containers are shared between those containers. Any questions on the structure or on what Docker is in general? Okay. All right. So we'll see in the next example, and maybe if that's not clear, it will become clear afterwards. All right. So now we are ready to actually dive into things and try to run our first Docker commands. So what Docker allows you to do, so the Docker command allows you to do many things, but one of the first things that it allows you to do is to grab pre-built images out of the Docker Hub repository. So here in this example, we'll show how to grab this Alpine Linux container from Docker Hub. So you can have a look at Docker Hub. I'm going to show you quickly what it looks like here. It's a repository of Docker containers, and that's the one that we're going to look at. It's a base container that contains a very small Linux system that you can use to build additional, more complex containers. So to grab the Alpine container on your system, you just need to run docker pull Alpine, and in principle, this thing should happen, and then you should have it accessible locally. So I'm going to leave you a few minutes for that. Let me know if you have any questions or if anything breaks, or give me a thumbs up if everything seems to be working fine.
Yeah, Francois, where does this Alpine go in the current directory, or there is a place where all the...
So right, so Docker has a place where it stores all of those images for you. So in principle, you shouldn't be able to see it.
And any reason you choose that?
Because it's the smallest one.
Okay.
So that's, you know, for the purpose here, it doesn't take forever to download.
Perfect.
So it's the smallest one, but it's a full-featured system. So we'll see then how to use it. So let's assume that run, and if you have Docker installed, there's no reason why this wouldn't work in principle, but then again, sometimes. And so now we can try to use that container. So the first command that we saw was this docker pull. So that allows you to grab something out of Docker Hub. And now we can try to run it with this docker run command. So what docker run does is that it will execute a command from a given container. So here what we say is grab the Alpine container, and the -it flags is just so that we can have an interactive command, and run the shell from that container. And the next line that you see is just the prompt of that shell that you're now executing inside the container. And so you might be on a macOS system, but at that point you are virtually on a Linux system. And so you can do stuff, you can look around. So for instance, you can type ls, and what you'll see is the file system inside the container. And at that point, there is no way that you can actually see the system, the base system that you're running on. So any comments that you're running here will be running inside the container. And you can exit again by typing exit. Any questions here?
So, so this Alpine image is running as soon as I type my Docker command, even though I'm only telling it, run sh, run the bash, but the full image is running anyway.
Exactly. So what happens is that it's actually not a full OS. If it were full OS, you would need to start processes, you would need to run daemons, and you have the whole boot process. But what this is just an image of a bunch of libraries and executable that runs on top of the Docker engine. And the Docker engine is your OS, and it's already running in the background. So when you do that, it just grabs this container and executes, just plainly execute that command from that container. And there is no boot up time. So for instance, a use case for containers is, for instance, I've seen people using it for using LaTeX. Instead of having LaTeX installed on your Mac or the system, you can use LaTeX out of a container, and then you just run the command, and it takes just the same amount of time as it would take if it was running locally, but it's actually running out of container. And so you could use it, for instance, for compiling LaTeX documents every time outside of the containerized LaTeX. So at first, I would a few years ago when I first heard about that, I said, for sure, this cannot be efficient, and for sure, this is not a good way to do things. Actually, it is, and all major cloud computing systems are now using containerized systems, and even on large supercomputers, they would recommend that you actually containerize your environment and run things in containers. So there is no downside to containers in terms of efficiency. All right, so that was to run a bash command. So bash, requires you gives you a prompt, but you can run any commands outside of the containers, for instance, an ls. So if I do docker run Alpine Linux ls, I will see again, this command will run, but it will run inside my container. So I will see again the content of my container. So that's kind of stupid. And so the next step is actually something that Jean-Luc mentioned at the first question is, how do I actually do something useful on my own computer with things that are in the container? And so Docker allows you to define the -v flag. And so what that does is that it will take some repository, some directory in your local macOS system, and it will mount it inside the Docker container for you. So if you do something like that, so Docker run -v, this grabs the local folder where you are, and it will mount it inside the container at the root of the container in the work directory folder. So now if I do the same ls and work dir, you should be able to see the content of whatever files you have in the directory where you're executing this Docker command. And so that's a stupid ls, but this could be a LaTeX command, and here the path to your LaTeX files, and that would compile on your local machine all of your LaTeX documents. All right, any questions on those very basic first steps with Docker at this point?
So the PWD variable there, it's the local variable inside the container, right? And then
no. So that's a bash. That's a bit of bash magic. you can do echo $pwd on your command line, and that will give you the path to the folder in which you are.
Yeah.
Okay. So that's the folder on your Mac OS, which is getting mounted inside the container in the /workdir folder at the root of the container. Does that make sense?
Apart from, let me try. So apart from,
if you type this without the workdir at the end, you will see the same structure as before, the same files, except there will be an additional workdir directory, which is actually your local files that are being mounted inside the Docker.
But I have to have a workdir outside, no? Or it just creates it there?
No.
So Santi, if you replaced pwd with home, for example, that would be your root directory, and then whatever you call workdir is what it's going to be called on the container.
Okay. So it just basically copies that it mounts, as you say there. It mounts that workdir inside the image, as it says there. So it doesn't matter how. Okay.
Exactly. So you can use here. You can use any name you want, and if you do / any name you want, that folder will be accessible inside the container at the path that you've provided, and so it will add a folder here with the name that you've provided.
Okay.
Right. So that's how you can mount local folders inside the container to play with the files. Okay. So if there are no more questions, I'm going to move on to the next step. All right. And so the next step this time is going to be an exercise to actually address the problem that we want to solve, which is how do you provide a complete environment for someone to run your notebook. And so for that, we're going to work out of the example that Fadi has put together. So what we're going to do is go to this repository here. So I'll let you click on this link, and I'll encourage you to fork Fadi's notebooks by clicking the fork button at the top right of the thing. So that will create a copy of that repository, and you can create the copy inside your own GitHub account. Okay. And once this is done, when the clone has been done, you can clone it to your local computers by clicking the clone button. That will give you a link that you can copy, and then you can do Git Clone and the path that is being provided to you by GitHub. You can copy it here. So by default, I use this Git at GitHub thing because I'm using because I've set up SSH clones. If that's not the case, you should click the use HTTPS button here, and then clone with the HTTPS link. So I'm going to give you a few minutes to try to do that. Please ask if you have any questions.
Francois,
yes.
Are you planning to push anything back to these
Yes,
forks?
I am.
Okay, I see.
Which is why, I mean, both things can work, but I encourage you to create a fork because we'll try something afterwards. So you need to be able to modify the content of that repository. If nothing works, if you have not been able to fork it, you can grab the original one out of CosmoStat, but you won't be able to push to it. So part of the tutorial afterwards, you won't be able to. Right, but please let me know if anyone is being stuck at this point. If not, I'm going to assume that everything is okay. All right, so if everything works and you've been able to clone successfully, then you should be able to see that folder and to go inside that folder and see all of the files from Fadi's tutorial. And so here, if you want to try it out, in order to be able to run Fadi's tutorials, you would run Jupyter Notebook in this folder, and you would try to open the example Alpine notebook thing. So I'm going to, just to demonstrate how nothing works ever for anyone, I'm going to try to do that myself, and we'll see that it doesn't work. And that's not Fadi's fault, it's just me. I have like not installed things.
Francois, are we supposed to be able to see your terminal?
Yeah, no. I'm starting. So,
okay.
So I've just started Jupyter with the command that I just showed you. So that's my own Jupyter that works on my system. But because I'm living in the 21st century, I'm using Python and not Octave. So I don't have an Octave kernel. So I can see the notebook all right, and I can try to run it, but it will tell me what is this? It doesn't understand how to run any of that, and nothing works. Like none of the example work. So in principle, I could try to install Octave on my system, but that's not what we're going to try to do. All right. Any questions here? So if you've tried to start a Jupyter notebook, exit it, because then we'll try to do this in a better way. Cool. So at this point, what we should have is all of Fadi's files, and nothing works. And now we're going to try to use some Docker magic. Okay. So what we're going to try to do is to create a Docker container which contains everything that is needed to run a Jupyter notebook with Octave in it. And so in order to do this with Docker, what you need to define is what's called a Docker file. And so essentially, it's a very small, it's a file that describes what needs to be installed inside the container in order to do the application that you want. And so here is an example of a simple Docker file that allows you to run a notebook. So you can go ahead and open a new text file inside the folders that you've cloned that you should call Docker file. And inside the Docker file, you can add the following content. And so we're going to go over what this does line by line. So the first line is this from instruction. So what that means is that the container that we're going to build is not starting from scratch. It's starting from this base image. And we're basing it outside of the official Jupyter Notebook image. So what that allows us to do is to use a very good baseline where everything is already installed, and the only thing that we need to install on top of that is just the things that are specific to our application. So you can have a look. There is a link here that I'm not going to click because I don't want to break things, to the Docker Hub description of that image. So in general, when you want to create a new container, it's a good idea to try to find the best already made container that you can easily construct on top of without having to install a lot of things. So for instance, we could, instead of doing this here, we could have said Alpine, and we would have built our container out of the Alpine container that we already have. But that would have required us to install everything, like all of Python, all of Jupyter, and all of these things, which are already contained here. All right, so the first thing to remember is that you can inherit from some already defined container, and you should try to get the best container that already has as much as you need. So the next thing that we do is that you can think of what happens in this Docker file as Docker reading line by line and executing what you tell it to do. So the next thing is that we're going to switch from whatever user is currently in the container to a root user, because we want to install some systems packages. So we tell Docker to switch to root at this point, which it will do. And then we tell Docker to install a bunch of new packages. And so if you go to the original Jupyter-based notebook image, you would be able to see that it's an image that is based on an Ubuntu system. So that means that you have access to all of the Ubuntu tools for installing packages. And here is how you would install, for instance, Octave. So what happens here is that we have a run command. So what the Docker will do is that it will execute that command. It will first update its list of packages, and then it will install. The -y here is so that it doesn't ask you questions and just install what you ask it to install. It will install two new packages, gnuplot and Octave. So these are provided as Ubuntu packages, so you don't have anything to do. It will happen by itself. And the last instruction that is here is clean, which will clean any residual files that were introduced by this thing. So for instance, the caches.
François?
Yes.
I have a question. So in my example, it was a bit difficult to make the repository that I made to use it with Binder, and especially to install Octave specific packages. Would we be able to install the packages in advance with Docker?
Exactly. So if those packages, so we'll see two ways of installing things. So the first way is through apt-get. So that's Ubuntu packages. If you have dependencies that are Ubuntu packages, you can just add them to this command and they will be installed. So like Octave, or I don't know, like any other things that are, Ubuntu packages, you can do that there. But then most of the time, if you do something with Python, you also have some Python things that you might want to install with pip, and you can also do that afterwards.
Okay.
François, and where did you specify that it's Ubuntu kind of Docker, or just with the run?
Right. So that's, so we'll see. We'll try to see it at the end of this page. This is defined in the parent Docker, in the parent container. So this base notebook container, the official Jupyter notebook, is built out of Ubuntu. So if we inherit from it, we inherit everything from it, and in particular, we inherit the package manager. So if you fancied, you could rebuild all of that out of an Alpine Linux, and then you would use the Alpine Linux package manager, which is not apt-get.
Okay.
All right. So the last point that I wanted to highlight is that this run command is actually defining a layer. So if you remember when I said that Docker containers are built layer by layers, one run command adds one layer on top of the previous package. And so what we do here is we install a bunch of things as one layer, and we make sure that any temporary caches or files that were used by apt-get in the middle gets removed before the layer is being constructed. So the layer is being constructed at the end of all of that. And so that allows you to remove any temporary files that you don't actually want to package with the end application. So just to save a little bit of space and remove things that are not useful. Anyway, so that's how you installed apt packages. And then the last thing that is done in this Docker file is to actually install the Octave kernel for Jupyter. And so this is something that you install with pip, that is not available in the apt-get Ubuntu packages. And that's just to show you that you can switch to the normal user. Now it no longer needs to be a root user, so that's how you change users. And that's how you run a pip install to install any additional dependencies. And so that's where we install the Octave kernel that allows you to run Octave things inside Jupyter. All right. Any questions?
So here for pip, I don't have to specify -- user or something, which I usually would have to do, right?
Yes. So here you don't have to because the system is already set up in the parent thing so that you can install pip files this way. Depending on the base layer, I mean, you could add -- user and it would work just as well here. It depends on the system.
The Jovian name, I get it from the link in principle.
So
the
yes.
link to the parent.
So right. So now, okay. So let me give you a little bit more detail. So that's all that we need to actually define a Jupyter Octave environment. That's shockingly low amount of code. So how can that be? And so let's have a look at the base image that we are building on top of. So I hope that's not going to flash for you. But here I have linked the Docker file for the base image. And you'll see that it's a little bit longer than the one that we have. And so what it does is that it installs a bunch of things. It installs a conda environment and everything. It sets up everything that you need to set up in order to run notebooks and everything. And so we are reusing all of that without having to specify it. And so, when you build on top of an existing Docker image, you should have a look at the original thing. So one of the things that it will set up for you is a user, a generic user that's called Jovian, and that's the one that we use to install packages. Okay, cool. All right, so that's how you build this Docker file, and next we'll show how to actually build the container out of that. Any last questions between the next step? Cool. All right. So now you have this Docker file with the content that we've defined. It should be inside your clone of Fadi's notebooks. And here is how you build the container. So you type docker build -t is to give a tag to the container that you will build. So it's good to use a tag name that means something. So you could use anything you want here, but we're going to call it Jupyter Octave. And this is the path to the Docker file. So it should be the local directory in which you are. And so if you run this, you will see a bunch of things that happens. What you'll see that it will first grab all the layers that are from the base container that you're using. And then what you'll see that it will start running one by one the run commands that you've specified. And you should see a bunch of things that are reminiscent of what happens when you install a package on Ubuntu or with pip. And hopefully this cannot fail in principle. And so you let it run, and at the end, it should give you a result.
So what happens if you, in your Docker file, give a command to install something that's already there? It just ignores it.
It's just okay. It's like as if you install something that's already installed on your computer.
On my Linux system, yeah.
Let me know if you guys have been able to run this.
Yeah, it's running.
I don't know if someone else has some troubles with when it downloads the stuff, like it's retries and retries some stuff, and then it like doesn't work. It was the same thing for the Alpine, so I had to do it like a couple of times till it worked. Maybe I don't know if my internet or.
So that's
I think
probably your internet. Sorry.
Okay. What happens if, for example, I do this in a Raspberry Pi and my Docker starts downloading too many things, and I don't know, the file system gets full, like my disk space or something?
Right. So one of the good things that, as I said, with containers is that they reuse most of the same things again and again and again. So like if you install 10 different notebooks or notebook environments, but they are all based on the same Ubuntu system, you get the base Ubuntu system once, and then just the deltas for application-specific containers. So that saves space. So you should be okay.
All right. But it has some sort of like switch that before it fills your disk. Imagine the Docker is huge. No.
No, it doesn't. So yeah, be careful. All right. Did anyone? I'm gonna, instead of asking when everybody has done it, did anyone manage to do it?
Yes.
Yes.
Sweet. Did it work?
Oh, mine is still running.
Okay.
Mine is still running. Yeah.
It's 1 gigabyte of space.
One? No. It's supposed to be 200 megabytes. All right. So
it downloaded around 200, but then it says after this operation, 1 gigabyte of space will be used.
Okay.
I'm having an error. It's like it's running, and then it's telling me that the error response from daemon cannot locate specified Docker file.
So what?
So the error is like it cannot locate specified Docker file. So it's.
But are you so the Docker file should be in the same folder as where you run this command?
Yeah, it's in the same folder, and it doesn't have any extension. It's just a.
It's
Docker
called
file.
Docker file.
Yeah.
That should work.
Sorry,
Fadi.
I'm trying. like it starts building and then it breaks, it stops the whole process and returns the error.
Okay, so
that's weird.
In case this doesn't work on your own computer, the next step that we're going to see is how do you build this automatically online so that you don't actually have to build it on your computer.
Okay.
So bear with me. I will try to show you what happens if now I run this command. So if some of you have actually managed to run it, you can do it as well. So inside this folder where we have, let's see, where we have all our notebooks, I can run this docker run command. And what you would see here is that we're using the same -v magic as before. So that means that we are going to mount the local folder somewhere inside the container. We also have this -p. And what that does is that it will forward the ports between the container and your system. So I've just launched this command. It gives me something that looks like that. And at the end, the last line of this command is a link that starts with 128, 127, blah, blah, blah. And I can copy that link inside my web browser. And here I am. And so what I see here is, again, a Jupyter environment. But this time, it's not the one from my computer. It's the one from the Docker container. So I can go inside the work tier. And here I see all of the files from Fadi's directory. And I can go inside the example notebook. And now I should be able to run it. So let's cross our fingers. This is the notebook. Let's see if I can get the doc. And yeah, everything works. So I don't actually know what's going on here, but just to show you that you can run the code and there's no issues.
It didn't work for me. So when I open it, I could not find a kernel matching Octave, which is the same thing I got before.
Oh wait. So you ran everything?
Yeah, so I ran the Jupyter thing, sorry, the Docker thing, the Docker file, everything ran fine, finished.
So try to change the kernel. So in kernel.
Yeah, I don't have any other. I just have Python 3. There where you are? Yes.
Wait, no,
I just have Python 3.
Did you run this?
Yes, and I clicked on the link. Yeah, I copied the link and let me try again. I don't know.
That is not possible. Are you sure you don't have another Jupyter running somewhere?
Let me see. I'm
because
even in
if that port
it could be. It could be.
If that port is already running, there might be a conflict and it might be ending up on your own system.
Yeah, I have another Jupyter, so I'm gonna close it.
So close that one and restart this.
Let me see if that works.
Any other questions? All right, so we'll give a few more minutes to Santi so that he can try, but that's essentially all there is to it on how to build your Docker container. And so the only issue that you might have here is that one, you have to do it on your local computer, so it takes a bit of bandwidth, it takes local space. And the second problem is that this container only lives on your system, and you don't want people to have to build it themselves. So how do you distribute this container, and how to make sure people can easily grab it online? And so that's the last step that we're going to see, is that you can actually put this Docker file on a GitHub repo and then have Docker Hub automatically compile Docker containers for your repo without you having to do anything.
1 second, I'm still having the same problem. Super weird.
Do you see, I mean, that shouldn't be able to happen if you've used the same Docker file image.
Yeah,
have you
tried? I had, like, before running that command, I had successfully tagged Jupyter Octave latest and all that stuff. And then I run this Docker run. I have to run it with sudo, otherwise it doesn't work.
No, that's,
so maybe, so the command that you showed, it doesn't work if I don't run it without sudo. That one.
Okay,
yeah.
That's fair.
When I run it with sudo, it creates it shows everything as if you were opening a Jupyter. And then I copy the link, open it in a browser, clean browser, and I only see Python 3 kernel.
But do you see when you start it? Do you see this thing?
Just work. Yeah, I click on work. Yeah.
I don't know. I literally copied everything that I've done.
I'm actually literally doing the same things. It's
so
really
the only possibility is that maybe you're liking one of these lines. I don't know.
Yeah, let me check. Yeah, let me check. Yeah, I don't think so because I did see this export Octave executable in one of the comments, but I'll try.
All right. So okay, we can sort this out afterwards if you want. All right. So the last thing that I want to show you is how to avoid these issues and by not building the containers yourselves on your own machine. So what we're going to do.
Francois, just a second before moving on.
Go ahead.
So if I understood correctly, I could have built this container in another place, not in the same folder
yes.
It would have worked anyways, because at the end, I need to mount the directory where I have the notebook.
Exactly. So, so it doesn't matter where you build the thing. You just need to have a path to the folder where you can find the Docker file. So here we were inside already the same folder as where the Docker file is. So we just did dot, but you can do this anywhere.
Okay. Yes. Thanks.
All right. So let's try to automate all of this to make it even easier for people. So you should have the Docker file available in your local folder, which is a clone of Fadi's original repo. So what we're going to do is try to add it to GitHub. So you do git add Docker file, then you commit your modification to add this file to Git, and then you push. So if everything works, this should add Docker file to your clone of Fadi's original repository. I'm going to give you just 2 minutes to try that. And I'm going to show you what my own fork of Fadi's repo looks like, hopefully without starting to see a lot of blinking. All right, so that's my fork of Fadi's repo. And inside my fork, you can see that now there is a small Docker file. So you can also check that this is indeed the same Docker file that the one that I showed you before. So hopefully you should be able to do this. If there is an issue here, it might be because you need to log in on GitHub or things like that. But hopefully you know how to do that. All right. So now let's say that has worked. The next step is creating a Docker Hub account. So that will allow you to connect, to create, a place where you can put containers and connect it to your GitHub account. So if you don't have a Docker Hub already account, you can sign up for one. It takes 2 seconds. And if you already have one, you should try to sign in. I'm going to give you 2 minutes to try to do that. And if any of this is breaking at this point, let me know. If you're already way beyond this point, let me know as well.
Francois?
Yeah.
Sorry, to create the account, it requires a Docker ID.
Yep. So it can be anything you want.
So we define it.
Yeah. So I can't show you because I already have one. But,
okay.
So for instance, for simplicity, I use the same username as for GitHub. But
yeah. Okay.
Thank you.
But so Francois, in principle, I don't need to push everything to the Docker Hub. I just need to give the Docker file that I've written.
Yeah, exactly. Okay. So if you give just the Docker file that you've written, people in principle, but you see that sometimes it doesn't work, should be able to just do Docker build, and that will build the environment that you want. but that can take a little bit of time. So the idea is that if you push your thing to Docker Hub, then they will just need to pull it. They don't have to build it themselves.
Like we did with Alpine.
Exactly, yeah. All right, so assuming that you've been able to create a Docker Hub account, the next step that we are going to see is that you can connect your Docker Hub account to your GitHub account. So what that will allow you to do is to set up automatic builds that rebuild whatever Docker image that you have defined every time that there is a modification made to it on GitHub. So that's great because it allows you to package some software, for instance, and make sure that the Docker image for that software is always up to date with whatever modifications you make. So in order to connect, you just go on the right here on the Docker interface to account settings. And inside account settings, you can go to linked account. And there is a GitHub thing here with probably a connect button next to it. So if you click the connect button, it will send you to an interface where you can grant Docker Hub to access to some organization or some repositories that you control. So you can, for instance, so here I've connected my user account, and I've granted all access to all my repositories under my name to Docker Hub. So that in principle also shouldn't fail, but sometimes it does. Let me know if you have any issues. All right, so assuming that you've managed to link your account, now the last thing that we need to do is to actually create your container on Docker Hub. So what you do is that you go back to the main page of Docker Hub. I can show you here. And on the right, you have this big create repository thing. So you click create repository. You can give it a name. So let's say Jupyter Octave notebook, or whatever you want to call it. Just below, you can give some description, small container, whatever. I can type. Then you should leave it public because private repositories are limited. And then you can say, I want to build this container out of a GitHub account. So I select my GitHub account, and I select the Octave forks that I've made. Okay, and so the last thing that you need is a build rule so that it knows what to do, how to build your container. So I click the plus button next to the build rules here. I can specify out of which branch I want to build. So I want to build out of master. I want to tag it latest, and I want to, the Docker file is called Docker file, and it's at the root of the repository. So that should be easy. And that's it. The only thing that you need to do is click this create and build button. That I'm not going to do because I've already done it. And when you do that, what will happen is something like this. You will land on a page where you have defined your container here. It shows you the build status, and it shows you like the README for the repo that is linked to this container. So I can go, for instance, in the builds tab here, and I can see the build history for my container. So I can see that somewhere like 2 hours ago when I prepared this tutorial, I see that the build got queued, and then it got executed and succeeded. And I can see the history of all the builds here. And that's it. And so now my container is online. Anyone on Earth can retrieve it by doing docker pull fl Jupyter Octave, and that will download that container on your machine, and you can use it locally. That's the last step. So if you've been through all of these steps, you can replace here by your username and run this command, and that will allow you to grab the container that you can then use as we showed before.
That's cool. So if your container contains some code that needs to be compiled, of course. Let's say I have a Fortran code. Then I can basically distribute already the executables, basically the binary, whatever. And people don't have to do anything.
Yeah,
that's the point.
So for instance, if you let's say you have a code that depends on Cam or on class or on Athena or whatever, and you expect 90% of the users to struggle with compiling this, you can just put everything in a container, and then they just download the container and they can run class directly by doing something similar to what we did before. Docker run Santis container class. That's it.
But then, just to be sure, in this case, we just packaged, so the container just contains that Docker file. No, the container contains the whole GitHub repo, right?
No. So in this case, what we've built, we can include all of the files of the GitHub repo inside the container image. I haven't done it here. It's possible. But what we've built is just the environment that allows you to, see the files afterwards. So the thing is, for instance, these files that I see here, they are on my file system. So I can create a new file, and I will see this new file directly on my own folder, outside of Jupyter, outside of everything. If I had packaged the files inside the container, people are surprised sometimes because they will try to create a file and then they don't see it outside of, on their normal command line, because it's actually built inside the container and you can't access it from the outside. So that's why I did that. All right, and that's it, folks. You've survived through your first play with Docker, and of course it's a very, very short intro. There are many more features that we could talk about, but hopefully it shows you kind of like the steps in order to do the task, like the one that we had, how to package tools that you need in order for people to reproduce your research or your tutorials. So I'm going to stop here, and now it's time for all the questions that you might have.
Yeah, it looks really cool. It looks really great. If I have, say, some software package that I need to compile, I need maybe to go to different directories and so on, I can do this all in the Docker file. All these commands I can just put there that I need to build.
Yes.
And how do we test this? I don't want to maybe change the command and then have to build the whole Docker file again, because it takes quite some time.
So two things. So the first thing is that, let's have a look at the Docker file again. So in this Docker file that we defined, there is two runs, two steps. What happens when you build a Docker image is that this step creates a layer and this step creates another layer. If you modify the second step, it actually knows that it doesn't need to rerun this one, and it can use the already built layers. So if I go in and I add another pip package to install, it's going to be super fast because it reuses all of the previous layers. So that's one answer to your question. And the second answer is that, as we saw in the first example of here, you can actually go inside the container first, try to run the commands. So I could here run the equivalent of apt-get to install everything I need and check that I know how to compile my code and that everything runs. And then you can repeat the steps that you know should run inside the Docker file. And then Docker will run the steps for you automatically. So you can rehearse, on the command line inside the container. And then when you know this works, you can, put it in Docker file. Any other questions?
So I need to, in order to do the Docker pull my username and this example, I need to wait for it to finish building, right?
Yes.
It's still building for me on the Docker hub.
Yes. So it takes a little bit of time, but one thing that I'll say is that we have enabled by default build caching, so that as we said before, it's going to remember all the layers that are needed inside your container. So that now if you go in and change just the last part of the Docker file, the build will be very fast. because it reuses everything that's already, done. So the first one takes a little bit of time, and the second one should be fast. In general, it's probably faster to build on your computer, but when you set it up this way, you're sure that things get automatically updated, and you don't need to think about it. So you can go to the builds tab and see what's going on and see how long it's taking and stuff like that. So like apparently this one took 20 minutes. Like it waited in the queue for 20 minutes, and then the build time was 4 minutes. All right, we are 10 minutes over the hour, so maybe we can stop here.